This video is going to just step you through the arrays concepts again as a little bit of a review. And so we're going to look at how you store data in an array, what an array is, etc. So remember that an array is just a list of variables in the memory, and all the variables share the same name, but each different data item is going to have a different subscript. The other thing that is true in arrays is that all the data will have the same data type, like they will all be strings or all be integers. The subscript is the position of an item in an array. Subscripts are always sequences of integers. They cannot be negative, and they cannot be decimal numbers. Each item will have the same name and the same data type. We call the items in the array elements. And array elements are stored contiguously in memory, which means they are right next to each other in memory. They aren't scattered all over the hard drive. For example, the size of an array is the number of elements. We use a special notation for the subscripts or the indices that indicate the position. And when you add data to arrays, that's called populating the array. So when we filled up the piano array, we populated it. The contiguous in memory, this is an example of it. It shows that the beginning of the array starts here, and then every array element is basically attached to that, and if we add to it, it would be attached to that in memory. And so the first element is always at the 0th location or 0th index. So the skinny notes, same name, same data type, different values and different subscripts. The different values are called elements, and the subscripts always start at 0. It is often typical to use a constant to declare the size of an array, and the reason for that is you avoid what we would call magic numbers, which are numbers that we don't know what they mean in the program. If we take a look at the program and in a year, we might not recognize what that number is. It also makes resizing an array easier and processing the array easier. It makes the code easier to maintain, and it makes it easy to change the size of the array. So you should always declare a constant for the size of the array, and we practice doing that on some of our review sheets. But to declare a constant in Java, you use the keyword final. Int, in this case, is going to be the data type because we're sizing an array, so it's just the number of elements. And then a capital letters, and it's assigned 10. So if this line of code is executed, the variable size cannot be reallocated or reused for anything else in that program. You could, and you can't change the value of it while it's running. Here's an example. So you create a constant called size. It's assigned 2. And then when you create the array, though, you have to use that constant here inside the brackets. So to create an array, you have to include the data type, a bracket, the name of the array, and you have to use this new keyword, so that tells it that you're setting aside new memory. And then again, you have the data type, and then size is used inside here. You could put the number 2 in there, but it's best practice to use a constant. These two lines of code, 6 and 7, are filling the array with elements. Element 0 has a value of 5, and then the value at subscript 1 is 6. So num sub 1 is 6 and num sub 0 is 5 is how we would say that. To print them, we would print nums bracket 0, nums bracket 1, and that would output the value that's stored in that element. So notice you have the same name but different subscripts, and those elements have different values. They could be the same value, but most of the time they're different. This is an example of storing values in an array, and this array here, we did not use it to declare the new array. We filled the array on the fly. This is appropriate to do string, month, bracket, and then it's assigned, and then the values. But then we use that constant size here to process the loop with a for loop, or to process the array with a for loop. It's very common to process an array with a for loop. You start the index at 0, you go less than size, and you increment by 1 to output. And here's what the output looks like. So a different example of how to fill an array, but also how you still would like use a constant value to help control that. Indicating again the for loop is often used to process an array. If you don't have the preset size, which is an example of what you just saw, you can just assign using the curly braces. This is an example of the GreenFoot piano when you had the letters and the white notes. This is also an example of parallel arrays. Parallel arrays are arrays that have a one-to-one correspondence between their values. They don't have to be the same data type. These could all be numbers and these could still all be strings. Sometimes they're the same data type, sometimes they're not. This is an example of processing the whiteKeys as you guys have done, so you pay attention to the bracket notation. And then this is a new way to actually find how many elements are in the array. If you don't have that constant variable, you can use a dot length method, and that dot length method helps determine, not helps, but it is the length of the array. It's how many elements are in the array. And then this is also an example of showing the parallel arrays. whiteKeys bracket I corresponds with white notes bracket I. So the application of parallel arrays is used here. This is just another example of declaring an array without knowing its size using an initialization list that has to be inside these curly braces here. And then it uses nums.length in order to control the loop. And that's just another example of declaring and processing an array. We've already talked a little bit about parallel arrays, so you can look at this in a little bit more detail. Other examples of parallel arrays are using like item numbers and item prices. Each element in the array is associated with an element in the same relative position in the other array. This is an example of a parallel arrays where you have different data types. These would be integers for the item number, and these would be decimals or floats, or we would call them doubles. Remaining within the array bounds is always something that you want to be careful of, because an array has a finite size. You cannot go beyond the array bounds, and when you do that, you're going to get probably an array index out of bounds error. And so just be careful of that. Other things, let's see, arrays are composed of elements of the same data type. This is just a little bit of review. Elements of the same data type can occupy the same number of bytes in memory. The number of bytes in an array is always multiplied by the number of array elements. So if you actually needed to find the literal size of the array in memory, you could do that. And then you can access the data using a subscript containing that value. So a little bit of review. When you go beyond the array bounds, here's an example of the error message that you get. So I tried to go beyond the array here. There are 1, 2, 3, 4, 5 elements, but remember the largest subscript that you can use is 4 because the indices start at 0. So the 2 would have an index of 0, 4 would have an index of 1, so 10 actually has an index of 4. And so that's the array message you get. An index array subscript is a logic error, and that means that you can't, it's something that we as users are making. An out of bounds error is using a subscript that's not within the acceptable range, and it could go beyond the range or it could go negative. That could also be an error. So you should try to prevent those. A for loop is often used to process an array, as you have seen. Make sure that you're always checking it to go less than the size instead of less than or equal to. This is just a different error variation or showing you pseudocode of a for loop, so similar to the screens that we've already seen. An example in GreenFoot using a for loop. It is not an example of an array, it's just using a for loop. This is an example of a for each loop. The difference in the for each loop is that it automatically does your initialization, the guard, and the update for you. You just have to use this special notation to say that you are going to access this leaf, and it's going to access every leaf in leaves. So this is from your chapter 7 project, but the data type here is always or the first thing here is a data type, and then this is an actual object in the array, and then it has to be, you have to tell it what list you're getting it from. So this is going to say basically for every piece of data of type leaf in leaves, I'm going to process it, and then you use, every time it goes through the loop, it actually pulls out the next element. So it pulls out the next leaf. So it takes a whole entire list of leaves and it processes all of them using this. It's a special loop. Another example of going beyond the array bounds is less than or equal to, and here is the error message that you get. The other thing you might get some questions on is searching an array, and there's an algorithm for searching an array. We talked about this in class, but it's often something that you want to do, and the algorithm is here. You basically start your subscripts at 0 because you want to start at the first element. You initialize a flag variable to false, indicating that you did not find the element. You look at each array element, and this has to be done inside a loop. And then if the value matches, you set the flag to true. If the value does not match, you increment the subscript. In our lecture notes, there are some, there is some pseudocode that follows this, so you can look at your lecture notes or your note packet. And there's part of it that asks you to identify the different steps for searching an array. And example question here, does GreenFoot use a search to play a piano sound? And so while it's playing the piano sound, it's looking at all of these. It doesn't, the question is, sorry, does GreenFoot use a search? And basically I'm going to say that it sort of does, because it's going to check to see what key you have pressed, and then based upon what key you have pressed, it puts a value in here. But in this actual for loop, this is just adding the objects to the screen. So this is not doing a search. So GreenFoot doesn't use a search because it's going to, it might look like it's going to, but you're actually going to send in a value based upon the key that you pressed. So the answer to this question is no. It might look like it uses a search, but it actually doesn't. And then you have your summary screens. And you guys can read through these and take notes as needed on your note packets. And the following is an extension lecture, which I am not going to go into. That is it.